Hi, good morning, and welcome to the ZP Developer Zone webinar. So we like to do this webinar a couple of times a week, and it's really just answering technical questions that have come in during the week. So one of the questions this week, and we'll jump into it, will be around the integration between electrochemistry and lateral flow. And one of the one of the questions will be around the detection of mycotoxins on crops. But a lot of what we're going to talk about today, whether you're interested in measuring sort of fungal infections or the toxins associated with those, or whether you're interested in actually making a integration between lateral flow and electrochemical sensors, then really the heart of all of this will be the Sensi All platform. And this is just really our way of getting technology from the lab and into the hands of real users who can benefit in the shortest possible manner. I just want to say a quick hi to Ali this morning. Ali, appreciate you coming on this morning. Ali's been a really good friend to us for years now, actually. So thank you very much. That said, I'll go forward and just say there is a webinar on the 27th of February. I'm super interested in anyone who's interested in things like water testing and analytes in water testing. Some of the things that we're starting to bring on now to the Sensi All platform is detection of things like freely available chlorine, and we're starting to bring some of our technology also into the sort of sanitization of water type applications as well. So super keen to hear from anyone who's interested in water analysis and maybe the sanitization I should say of water. And there is a webinar on the 27th of February that might be super interesting. Webinar is also super interesting to the people who want to do the mycotoxin detection, and also the people who do want to do lateral flow strip integration as well. It's probably just worth saying that ZP does do a lot of corporate and consulting workshops. Just please reach out to us if you're so interested in that. And we also are doing a in vitro diagnostics and continuous monitoring workshop on the in March 2024. So just want to put a quick link to that as well. If any links jump up, by the way, I'll make sure I post them underneath the video at the end. Also, we did have a very successful S Cubed conference in last year. We're going to do another one in the UK this year, and we were delighted that Ali actually spoke at that conference as well. And to be honest with you, I think it was energy-wise, it was one of the most high amounts of energy that I've actually seen at a, let's say a sort of technical conference in years. I must admit, it makes me think more like an apple than it does make me think of electrochemistry. To the questions today is the detection of ochratoxin. I'll show the structure of ochratoxin. I know it's a sort of, I think it's a, ochratoxin is a sort of mycotoxin that comes from fungus that grows on crops. And I'll also talk about the integration of lateral flow with SPE. So question number one about ochratoxins. This is something that at ZP we've been sort of super interested in it for years, looking at all these mycotoxins. As the questioner knows, these molecules, and there's the ochratoxin A, they're all highly electrochemically active. So actually you can do a complex or a more complicated assay, obviously using aptamers. The molecules are also intrinsically electrochemically active, and I can see that there's a lot of precedence out there for just doing sort of direct or slightly modified electrode detection of these toxins. Now, my recommendation on this is going to be our hypervalue carbon electrode, or our, I think it's called the 501 circular electrode here. These are both carbon. The fact that those ochratoxins are very sort of aromatic rings on them, they'll be readily active upon these carbon electrodes. And I did a little bit of reading, and of course, you can quickly find papers that describe this. I think, in this modern world, if you want to do sort of direct analysis of these kind of organic molecules, then I think square wave voltammetry and differential pulse voltammetry appear to be the most sensitive methods. And I would agree that in our own experience, if we try to make sensitivity, then we would tend to use these methods as well. Now, the reason I bring this up is because if this is the kind of methodology that ends up being developed, whether it's square wave voltammetry, differential pulse voltammetry, we don't really mind. We can actually convert this kind of assay into a QR code, and then that QR code will fit really nicely then into our workflow. So as long as this person adopts our screen printed electrodes and develops an electrochemical assay, that means by developing an electrochemical assay, it means that the conditions of that assay, the methodology, start potential, end potential, scan rate, all these sort of parameters, we can turn them into a QR code, at which point then they're actually able to use our Sensi-All platform. So if they want to deliver this to real people, you know, like coffee producers or packers, etc., or people involved with the warehousing, they can do it because of the Sensi-All platform. So anyone who's an electrochemist or an electrochemical assay developer, just know that you're so close to being able to make a tangible product. It's just getting onto the Sensi-All platform. Come to our webinar in February to see this in action. But I bring this up because this person might end up developing an electrochemical assay for ochratoxin, at which point they will know all the conditions, therefore a QR code can be generated. If they use our screen printed carbon electrode, that means now that I have a electrode that I trust and has the right connectivity, and we know the method file. So what will end up happening is those sensors that they end up developing will fit into the Sensi-All platform. The app will read the QR code. So at this point, the app gets repositioned to do ochratoxin testing. They put the sample onto the sensor, and the app will tell the hardware what to do. The hardware will give the data back to the app, and the app will convert the data into, depending on the units, because this might be ppm, parts per million, it's probably be that kind of industry. But also they'll get all the voltammetry data going up to the cloud. So you can give it to a coffee producer, they will do the testing, they will get the number ppm, and you as a developer, because you're the one who wants to kind of keep, especially when you've got alpha and beta customers, will get the raw data up in your cloud. At which point then you can share it with yourself, or you can share it with third parties like ZP to kind of troubleshoot any kind of issues. But what it means is that you can get from your lab work, which would seem very lab-like, to actually a tangible product, probably within a 3-month period. And it's only just the conversations that will really take that long. So here's the philosophy. So you've got somebody who's producing coffee. The coffee needs to be checked to make sure that it doesn't have these kind of molds upon it. You want to develop them a hardware solution. It seems like you are a very, you would feel like you're a long way from giving them a solution when you're not. Because as long as you're using electrochemistry, as long as you're using sort of things like screen printed electrodes from ZP, and you'll see that the Sensi-All platform was also a piece of hardware already developed. You're really close to actually being able to give people solutions. In the past, people would have to invent this hardware part, and actually it would never be robust, it would never be pretty, it would never be easy to use, and it costs millions of euros just to get that kind of robustness together. But we have it. It's called Sensi-All. Come to the webinar 27th of February. So this end user actually gets some hardware. They get a QR code which reflects the final assay that you developed. They scan the QR code on their phone, they're good to go. So they start testing. All the data goes to the cloud. It's a system called Julie. At which point then you can see the raw data in the cloud. So they get a number, you get the raw data. You can check that raw data. Does it look good? Yes, no. If it's not good, we can work on the method file to actually get the number out of the raw signal, or come up with algorithms to kind of reject obvious outliers. But you can work on that now. So you're not in the lab just doing testing and trying to improve. No, you're actually made something. It's 80% good. You give it to the end user and you start getting real world feedback. This is lean startup mentality. People wait too long in order to deliver products to the market, and in the end actually nothing ever gets delivered to the market, let's say. So just to say that please adopt our screen printed electrodes, because this is the route that you're then on. Now what you'll notice, this person came to one of our food sense demos the other day, so I appreciate that. What you'll notice is when we were doing those demos, there was never a calibration step involved. In fact, that was the kind of result that we got during the webinar. That's in Scoville heat units, by the way. There was no calibration involved. And that's another fundamental aspect of our screen printed electrodes, is they're really reproducible. So when we're manufacturing, we'll make them in sheets like this. We'll test the sheet, and we'll make sure that, and if a sheet looks like this, we'll reject it because the voltammetry is not reproducible on the sheet. Then we'll test another sheet. Is the voltammetry reproducible? 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 And then we'll basically, here we're looking at peak height. This is 5.6 to 6.2. So we're quite zoomed in on the peak height here. And we'll just check the sheets and make sure that we understand what their sort of relative standard deviation is and what their absolute differences are on that data. And that's why, because we're doing this much testing, that we do it for ourselves, but actually what it then means is that when we kind of deliver these screen printed electrodes to you, you have a very reproducible screen printed electrode. That means then you don't have to worry about calibration in the fields, because as soon as you try to introduce calibration in the field for your end users, you're taking a big step away from being able to give an easy to use, low cost product, because now you're going to have to introduce a calibration step. So with our kind of voltammetry work, you'll often see that these are triplet kits, by the way. At each concentration, you'll see that we've got very tight kind of data and all a low relative standard deviation on our data because of the underlying reproducibility of our screen printed electrodes. So I do hope that this person does adopt our screen printed electrodes. Probably for these people, it'll probably be the 501 because it's a circular electrode. It's easy to pipette onto. But then they're really set up for being on our OEM solution, our original equipment solution called Sense It All, where they can actually make a product. We'll have no slots, nice cartridges, very cleanable. I really like. I just got some feedback from Ali as well. This is what Ali's saying online as well. So Ali's just following live as well, and I agree with Ali saying because he gets it. See that validation in the field is it is a real game changer, because so much validation, you can do it in your lab, but it's almost like you're a simulated system, and you don't, and so you can actually validate with real people. And in the first instance, you don't have to blind them. Sorry, you can blind them to the results. You can just say, look, you're my alpha tester. I want you to test samples. I'm not going to show you the results. I'm just going to be checking the data. But you're checking more about the usability of the device at that point. But you're also getting the raw data. That you're getting the raw data. So Ali gets it as well. So the whole thing about ZP is we've been around now. This is our 10th year, and this has always been the end goal for us, is actually to give a technology platform to accelerate ideas to market. And it's just the experience. Let's say this is what we're up to. So this is the hardware. Look, no slots. They can just put the sensor in there. Elegant cartridge, and you can pick it up nicely. Cleanable, especially with this. If there gets some sort of dust or even mycotoxins on this, you'll see that you can pull it apart and clean it down. LED lights. Is it on? Is it running the assay? Is it making Bluetooth connection? Is the assay uploading? That's all guided by the LED lights. You can use it with Android and Apple. This is great. Not laptops. Not those kind of operating systems. No, modern phones in people's pockets. It's cloud enabled. This cloud enabled means that you can validate with real people, and you can see the raw data. There's also something called order fulfillment. So if you're an academic or you're a small company, order fulfillment, manufacturing and order fulfillment is a real pain. You have to have somebody, you have to put it in a box, you have to print the shipping label, you have to order where it's actually, or book where it's actually going to. There's a lot of admin around this. So I'll talk about the order fulfillment in a minute. It's also priced for the OEM market. What I mean by priced is the normal price for just one unit on its own is like 1,699 euros. But once people are able to order 10,000 of these, which is not a massive volume, they're actually 60 euros each. So suddenly they really make sense, and so we got to kind of scale. So they're priced competitively to be real products, compatible with microfluidic cartridges, which is actually a good point because the lateral flow strip question that will appear in question 2 today is a I won't call it lateral flow, but it's definitely capillary fill, and it would be compatible with that, and I do illustrate that. So whether you're interested in doing ochratoxin testing or integration of lateral flow or interested in water testing, please come to our webinar on the 27th of February, and I'll try to put a link underneath this video. We do one in the morning, one in the evening, in European time that is, and we'll do a live demo. This is what the platform looks like, very elegant, really sort of, much more of a consumer style product. It runs all the amperometric, potentiometric, voltammetric, and impedance spectroscopy techniques. And for me, intellectually, what it does is that otherwise people are in the lab using instruments like this, and I have instruments like this in my garage. I have 4 of these CH instruments. On the academic front, people are using equipment that looks like scientific equipment, and that's because they're doing scientific experiments. But once you start using instruments that look like this, the gap between your thinking of, well, I'm doing a lab experiment, and actually doing a product development, that gap suddenly narrows and blurs. So then you're thinking to yourself, I am no longer doing scientific experiments for a scientific paper. I might well be doing that. But what I'm really doing is actually product development. And it's this platform that really changes the mindset that actually you're here to make an impact on society now. You're not here to give society another paper that, may get 5 citations, 5 citations. Earlier on, I was mentioning that this platform, and I was mentioning in particular for coffee testing, the fact is that this is the device. It's got a very nice kind of user experience. In a bit, when you watch that video in the top left-hand corner, what you will see is, these are the cartridges, so you can see that there's a really nice kind of user experience. So make sure that you do get those 501s or those hypervalued carbon electrodes from us, because then you're kind of already half onto this platform, more than half onto the platform. You're at the root of the platform, because the root of the platform is the screen printed reproducible carbon electrodes or reproducible screen printed electrodes from Zimmer Peacock. This is the bit I wanted to show you when I took it apart. See that? So that means then you could clean that down, especially with, if you've got a fear of toxins contaminating something, you can take it apart, give it a wipe down as well. It's the same for the person who's going to ask about lateral flow strips in a bit. I have, obviously done lateral flow strips. We all have. And you can get blood from those onto the device, so you do need a way of cleaning it. In this video, this is really a demo what we'll do on the 27th of February, where we show the hardware, we show the Bluetooth connection, Solron puts a sample onto the device here, and then the data goes to the cloud. So make sure you come and see that. This is in particular now to people who actually want to do multi-analyte testing. So today I'm talking about mycotoxin testing. If you wanted to do another type of analyte, we can generate QR codes for each particular analyte you're interested in. So this little box is a multi-analyte system. So often when you've got these lab in a box type instruments, they're set up for one test. But because of the power of electrochemical techniques, we, and the power of these electronics, we can essentially tell the SensiAll platform what to do just by scanning a QR code, and then the QR code will direct the app what to do, and the app will direct the box what to do. So we can quickly change assay, no probs. So in particular for ochratoxin testing, we've got a whole bunch of leading screen printed electrodes. I put them here. There'll also be a link in a minute. But for you, I think it's the 501 is really going to be the one for you. You can use the hypervalued carbon electrode. It's just if you're going to modify the electrode, you may find the circular electrodes easier to pipette onto. And I'll put some links here, and hopefully you will get them. If you're not going to use our Kate potentiostat, you will need a connector. So I'm going to put a connector here as well, because the connector will go between your potentiostat and our screen printed electrode. Our screen printed electrode to one I've just linked are 7mm wide, so make sure you get the 7mm connector. And the link here will show you that we've got connectors that will take 2mm banana plugs, 3mm and 4mm. A lot of people, if you're using an Autolab potentiostat, those are 4mm. If you're using PalmSense potentiostats, those are 2mm. So make sure you size the connector accordingly. If you don't have a good connector, you will get bad data, because people try to use or make their own connectors. Those connectors end up being high impedance. High impedance distorts the data, so don't do it. This is in particular for people like Ali. If you can rewind this video later on and watch it, but the SensiAll platform. We got an app on that platform. That's basically a distribution app. So if you scan that QR code, that will install the app on your phone. And if you do this off your iPhone, that will install the same app on your phone. I still need to correct that spelling. But this is a video, so you can rewind and find that. And you'll find that by scanning these different QR codes, the app is able to do different assays. And we've just added glucose and potassium and nitrate to this as well. In fact, yeah, I might have even had nitrate on here. Yeah, I did. There we go. All right, so let me back up a little bit. So this person's in particular interested in ochratoxins. I'm saying that you'll probably end up doing an electrochemical technique. It'll probably be square wave or differential pulse voltammetry, in which case we can turn it into a QR code. Once it's a QR code, we can distribute it to thousands of users around the world just by using this QR code system that we already have on the App Store and the Android Store as well. If it's confusing, come to the Sense It All webinar on the 27th of February. Talking about drop shipping, this is maybe a little bit further on for my academic colleagues, but super relevant to my commercial colleagues. So there you are. You do the hardest thing in the world is actually find a client. But what that means then is that once you've got your client, you're actually able to send us an instruction to ZP. ZP then is able to take the sensors and take the meter, put them in a box and ship them to the actual client. Now that process can take 4 or 5 people in that loop. And normally with a startup, you'd have to end up hiring those 4 or 5 people. The salary bill alone, depending if it was in Europe, the salary bill alone, and in the US as well, could easily be for those 4 or 5 people, 200,000 a year. So you're going to have to start selling a lot of units just to afford your logistics. But with drop shipping, I mean, this is why you see these kind of entrepreneurs online that use Amazon fulfillment, because actually they understand that, they find products, or and they sell products. But if they were to try and do all the logistics themselves, it'd be a nightmare. But actually, with ZP, you can actually get us to do the logistics. So that's why it's another reason to get onto the Sense It All platform. Again, the webinar is on the 27th of February, so hopefully people come to that. It's a change of pace, not a change of pace, change of question now. So this has been going on for a few years now. People are very interested in integrating lateral flow strips with electrochemistry techniques. I mean, I like lateral flow techniques. They're good for sample prep. They work. They were shown to be very scalable during COVID-19. Problem with them is they're not digital. And what I mean by that is, that the end user often ends up interpreting the data. And what you can see about the Sense It All platform is if you can integrate a lateral flow strip with a screen printed electrode, you can essentially digitize the signal. And because of the Sense It All platform, you can send that raw signal out to the cloud. So now you actually have traceability. I think during the COVID-19 crisis, people would have liked that kind of traceability, because then you can kind of confirm that somebody was a true positive or true negative, or false positive and false negative. And it would have made the whole system a lot easier and more transparent. It's also important because lateral flow is used a lot in things like the food industry, where people want traceability. So, fundamentally, people are very interested in doing, lateral flow strips. I get it. They're quite good. You put a reagent or a reagent down on the nitrocellulose material. You put the sample onto there. You put like a solution onto the back end here. That solution kind of flows up, picks up the sample, brings it to the strip. And of course, it's essentially like a large filter. A lot of interfering materials are removed, and you end up with a sort of, sometimes a strong signal at the end here. Of course, then, that then means that, that person has to interpret that. But I can interpret those. Most people can interpret those. But to be fair, people who sometimes need to use lateral flow strips are not necessarily able to interpret them. And if this was in the food industry, you'd want the traceability anyway. Otherwise there's no digitization of that. So what you can do then, well, I just want to draw a comparison actually, because lateral flow strips, I've seen the connection between lateral flow strips and electrochemical sensors for years. Because this is a kind of glucose sensor. At ZP, we do ISO 13485 manufacturing. We can manufacture these things on behalf of other people. But you put you have an entrance, you have an air vent here. You put the sample on here, and the sample fills up this chamber by what's called capillary action. So I've always seen the comparison or the similarities between lateral flow and electrochemistry, and I've also been involved with people who are interested in actually integrating the two, let's say, techniques. So here we have the meter, we have the sensor on the front. Now this person's quite interested in maybe coming in from the sides, but I actually don't think you need to come in from the side. The problem with coming in from the side like this is I think it makes for a very large footprint device, and it's actually quite an awkward little device because you kind of got the sample coming in here and the electrical connections coming in here. I actually think it's quite hard to then make a device to receive this device. So I would actually say don't do this, because I know the way I would design the device is this. I would take one of our really low cost hyper value carbon electrodes. These are less than a sort of euro each. And I would actually mount the nitrocellulose this way. And I wish I'd actually put a bit more of a video on that, because I'd want the sample to come here. I'd want the sample to be put on in the middle. I'd have a wash solution here, and then it would just basically diffuse down to here. And it wouldn't come past here, because once the nitrocellulose is stopped, it's stopped. So this is actually the device that I would describe, because actually I think this is much more repeatable and able to turn into a user experience that people can really use. It's a little clunky to have this kind of perpendicular design here. So I'd actually go for the design that I've actually suggested. If you do that, what it means is that we are really able to, you are able to commercialize this much quicker, because you can take this new hybrid lateral flow screen printed electrode technology. You'll end up making an electrochemical technique, which can be converted to a QR code. The QR code can be read by the app. That new cartridge can go into the hardware, and at which point the sample can go on, the assay can run, the user will get the number, and again, as Ali was saying earlier on, then it's really easy to validate it because the raw data actually goes to the cloud, and so now you have truly digitized that signal. So my suggestion to these people is, don't do that perpendicular design. We can't do the electrodes at a low enough price that makes that attractive to you. We can make those hypervalue carbon electrodes at a low price and low volume that's attractive to you. And I think it actually makes for a better product, because I can see now that I make electrical connection at one end, you add the sample at the other end, so that keeps the electrical connection and the sample well away from one another. It makes it for quite a narrow strip, which we can put in tubes and pack really tightly in boxes. So I would definitely go for that particular design. It will end up having a much lower cost design, much lower cost of goods for manufacturing, and a much better user experience. So we do have a whole bunch of screen printed electrodes, but because of your kind of wish to detect the line, then I would end up using the hypervalue carbon electrode, and that would be one of the links that I have here. If you don't use our Kate potentiostat, which will be a link, and you hold off buying a Sensi all for a few years, then make sure you get the right connector. Our screen printed electrodes are 7mm in diameter. Get the 7mm diameter connector. Check your potentiostat. It's probably got 2 or 4mm banana plugs on it, and choose the right connector accordingly. As I say, I do prefer people starting to use this kind of hardware, because then they're becoming product developers rather than sort of just thinking of themselves as lab scientists. Maybe that's the sort of question number one. I think with you, use the 501 carbon electrode, and with question number two, I would actually say use the hypervalue carbon electrode with a rectangular fitting. And that's it. So thank you very much. So I appreciate the questions. You can see that we do put a lot of effort, a lot of thought into the questions. On the 27th of February, there is that webinar. People who are also interested in testing in the water industry, I hope you could come along as well. So I will sort of pause and wrap up there and say thank you very much and have a good week. Okay, thanks so much.